Okay, so this is question example 2 from chapter 4. Okay, example 2 from chapter 4. As you can see here, the question is compute V naught using mesh analysis. So given the circuit like this, okay, as you can see, you have three loops, three meshes or three loops, 1, 2, and 3. Okay, let's say I name this loop as I1, and then this is I2, and this is I3. Okay, so let's see the first loop. We're going to apply KVL for each of the loops in order to get the equations for this kind of circuits. Okay, so let's see the first loop, I1. Okay, as you can see, for this the first loop I1, we already have a current source here, 490 ampere. This unit is in ampere, so this is the symbol for current source. It's going that way. Okay, so we can simply take the value of I1. Okay, so I1 is equals to 4, and the angle is 90 ampere. Okay, this is similar to, we know that 90 we can change into complex number directly. It becomes J4. Okay, now what else we have? If you see here, I3, this is the mesh I3 or loop I3. Okay, loop I3 as well has the current source. It's note here the value is 2 and the angle is 0 ampere. Okay, so we can simply take the value as well. I3 is equals to 2, because the angle is 0. Okay, because the angle is 0, so we don't have to write the degree. Okay, is it correct like this? As you see, okay, please look carefully for I3. Okay, I3 is going to this way. It's a clockwise, right? Whereas the current for this current source is going that way, right? And I3 is going that way. I3 is going this way, and the current source is going this way. So as you can see, these two, okay, these two currents, the branch currents, which is applied by the source here, and the mesh current I3 is in different direction. Okay, they are in a different direction. So this current I3 here, okay, we must take the value a negative. A negative is inverse to this value. Okay, it's negative 2 because it's opposite in direction. Okay, so that is I3. Now we are going to find for one more loop, is I2. I2, we need to use KVL, Kirchhoff voltage law. Okay, and to get the expression, the equation for getting I2. Okay, so we start to do the KVL. Let's say I note it like this. For mesh 2, okay, use KVL. Okay, using KVL. Okay, for mesh 2, using KVL, okay, we start from, let's say we can start from here or anywhere you like. Anything from this loop, you can start anywhere. Okay, let's say I start from negative J3. Negative J3, this is loop for I2. Okay, and then go, I2 is going to clockwise, and we see this voltage source 12 and the degree 0 volt. Okay, and as you can see here, we see the positive sign first. So when we see the positive sign first, that means the voltage here is plus 12. Okay, plus 12, and degree 0 is okay. And then we go to the next one, is 2 ohms resistor here. Okay, so 2 ohms resistor here, it becomes plus 2I. Okay, so this time for this resistor is the meeting of two current source here, I1 and I2 mesh. Okay, so as you can see here, going to clockwise for this loop, I2, this is I2 for this branch, whereas I3 is going to clockwise as well, but going to this way for this branch. So this is I3. So it's opposite. As you can see, it is opposite direction. Since this is, we are solving for mesh 2, okay, so we assume the dominant current here is I2 minus I3. Okay, now go to the next, go around the circle, the loop mesh I2. Okay, now we go to a resistor, 2 ohms resistor, right? It's a 2 ohms resistor, so here it's going to be a plus, and the current is the same method, where I1 is going this way, so this is I1, and I2, and it's going this way, so this is I2 for this branch. Okay, for this branch. Okay, I mean, right, so it's I2 and I1 is in opposite direction, so we managed to get the 2 ohms times by, so I2 is dominant, I2 minus I1 equals to 0, the whole things. Okay, now we managed to get the whole, very long equation for mesh 2. Okay, now we try to simplify this long equation by grouping it according to the current. Okay, so let's kembangkan dahulu this one. So negative J3 I2 plus 12 plus 2I2 minus 2I3 plus 2I2 minus 2I1 equals to 0. So now I group it accordingly. Let's find for I1 first. Negative 2. Okay, so it's a negative 2 I1. And then the second one is I2. Okay, plus 2i2, and here is 2i2. We get 4. Okay, 4i2, and another one is here, negative j3i2. Okay, right. Okay, so done with i2, and now we go to i3. Let's see, i3 is negative 2 here. 2i3 is here. In the last one we have 12. Right here, this is the 12 value. Plus 12 equals to 0. Okay, so now let's see what is the question. The question is asking you to compute the value of V0 using mesh analysis. So where is V0? Here is V0. Okay, positive, negative, it's V0 is here. It's at 2 ohms resistor. Okay, so we know that. Let's see. Okay, so this is done. All of this done for the 3 loops of mesh. Okay, so now let's see the question. It's asking for V0, and we know that V0 is here. It's given in question. V0 is here. Okay, and we know as well we can use the Ohm's law as well. Okay, V equal to IR. Okay, R is given as 2 ohms here, whereas I is something that we need to find out. Okay, so we know from this node, okay, from these two nodes here to here, where the V0, okay, where the V0 point that we are going to find out. Okay, we know that what V0 is equals to V equals to IR. 2, the ohms, the resistor value is 2 ohms. Okay, 2 times, okay, here the current is I1, the resulting of I1 and I2. Okay, so we can assume that V0 is equals to I1 minus I2. Okay, so now we can get the value for this. We already know the value for I1, which is I1 is equals to J4, whereas I2 is the value that we need to find out from this equation. Okay, and we know already the value of I1 here, and then I3 here. Okay, we already know this is the value for I1 and I3, so we can fill up this value into this equation. Okay, so now let's say I name this as equation 1. Okay, I name this as equation 1. Okay, the next step is substitute I1 and I3 into equation 1. Okay, so we managed to get negative 2 I1 is J4. Okay, negative 2 I1 is J4 plus 4 minus J3 is still the same because we haven't found for I2 yet, and then minus 2 I3. 2 I3 is negative 2. Here I3 is a negative 2, and plus 12 equals to 0. Okay, so we solve this equation and simplify this equation, and we get this as 2 times 4, 8, J8 plus 4 minus J3 I2 minus plus 4 and plus 12. So it becomes plus 4 plus 12 is plus 16. Okay, equals to 0. All right, so now we are going to solve for I2. I2 is equals to negative 16, bring it all to the other side, negative 16 plus J8 divided by 4 minus J3. Okay, so now we solve this complex number division operation. Okay, and you manage to get the value for I2 is equals to negative 3.52 minus J 0.64. Okay, so this is the value that you should get. Okay, so now we can solve for V0 here. Okay, so the question is asking to find V0. So V0, go back to this equation that we found just now. V0 is equals to 2 times with I1 minus I2. We get this from the circuit. Okay, so now we can solve for V0. V0 is equals to 2 I1 minus I2. Okay, so equals to 2. I1 is J4, I2 is negative 3.52. Minus is positive 3.52, and then another one is minus as well, minus positive J 0.64. Okay, so we can solve here. So here we get 2 J 4.64 plus 3.52. So we solve this equation and we managed to get the value 7.04 plus J 9.28. Okay, so from this complex number we solve for phasor form. Okay, and we get 11.648, and the angle is 52.82 volts. So this is the answer. Okay.